copper corrosion in environments near saltwater can be a significant issue. The high salinity levels in these areas accelerate the corrosion process. There are several potential causes and mitigation methods to consider. Firstly, saltwater exposure is a primary concern. The high concentration of salt ions in the water acts as an electrolyte, facilitating electrochemical reactions that corrode copper. Secondly, chlorine used for disinfection, particularly in swimming pools or water fountains, can react with copper, leading to corrosion. Chlorine is an oxidizing agent, and its presence can accelerate the breakdown of copper. Thirdly, stray electrical currents can contribute to corrosion. Electrical currents leaking from nearby equipment or improperly grounded systems can create electrolysis. This process causes accelerated corrosion as electrons are transferred between the copper and the surrounding environment. Fourthly, low pH water can dissolve copper over time. Acidic water with a pH below 7.0 can leach copper ions from the metal, gradually weakening the plumbing system. To prevent and mitigate copper corrosion, several methods can be implemented. 1. Cathodic protection involves installing zinc plates or sacrificial anodes in the plumbing system. These anodes are made of a more reactive metal than copper, so they corrode preferentially, protecting the copper from electrochemical damage. The zinc acts as a sacrificial material, diverting the corrosive attack away from the copper component. 2. Copper-nickel alloys can be used for plumbing, heating, ventilation, and air conditioning, and other copper components. Alloys like 90/10 copper-nickel are more resistant to corrosion than pure copper, making them a suitable alternative in corrosive environments. The nickel content enhances the alloy's resistance to saltwater corrosion. 3. Protective coatings can be applied to copper surfaces to create a barrier against corrosion. Coatings such as epoxy or urethane paint can prevent corrosive substances from coming into direct contact with the copper. These coatings act as a physical barrier, preventing the electrochemical reactions that lead to corrosion. 4. Proper grounding of electrical systems is essential to prevent stray electrical currents from leaking into the plumbing system. Ensuring that all electrical equipment is correctly grounded minimizes the risk of electrolysis-induced corrosion. Grounding provides a safe path for electrical currents to flow, preventing them from straying into the plumbing. 5. pH adjustment can neutralize acidic water. If the water has a low pH, consider using a water softener or installing a pH adjustment system to raise the pH to a neutral level. Neutralizing the water reduces its corrosive potential, protecting the copper pipes from dissolution. 6. Regular flushing of the plumbing system can remove salt and chlorine buildup. Consider installing filters to remove impurities from the water. Flushing helps to eliminate corrosive substances that may have accumulated in the pipes, while filters prevent new impurities from entering the system. 7. Regular inspection of copper tubing for signs of corrosion and prompt repair or replacement of any damaged components is crucial. Early detection and intervention can prevent minor corrosion from escalating into more significant problems. Monitoring the condition of the copper pipes allows for timely maintenance and repairs. In addition to these methods, consider using plastic or stainless steel piping for areas where copper is prone to severe corrosion. These materials are inherently more resistant to corrosion than copper and can provide a longer-lasting solution. Avoid using galvanized fittings with copper piping, as this can create a galvanic cell that promotes corrosion. Galvanic corrosion occurs when two dissimilar metals are in contact in the presence of an electrolyte, leading to accelerated corrosion of the more reactive metal. Ensure the plumbing system is properly designed and installed to minimize contact with corrosive environments. Proper design and installation can help prevent the accumulation of corrosive substances and reduce the risk of corrosion. It is advisable to consult with a licensed plumber or corrosion expert for professional advice and guidance. These professionals can assess the specific conditions of the restaurant and provide tailored recommendations for corrosion prevention. For additional considerations, ensure that the copper pipes are properly insulated. Insulation helps to prevent condensation, which can contribute to corrosion. Condensation can create a moist environment that accelerates the corrosion process. Also, regularly check the water quality for any signs of contamination. Contaminants such as sulfates and nitrates can accelerate corrosion. Water quality testing can help identify and address any issues that may be contributing to corrosion. Another point is to implement a regular maintenance schedule. Regularly inspect and maintain the plumbing system to identify and address any potential problems before they become severe. Preventative maintenance can extend the lifespan of the copper pipes and reduce the risk of costly repairs. Another consideration to make is to use corrosion inhibitors. Chemical corrosion inhibitors can be added to the water to reduce its corrosivity. These inhibitors form a protective layer on the copper surface, preventing corrosion. Always follow the manufacturer's instructions when using corrosion inhibitors. Something to note is that you should avoid mixing different types of metals in the plumbing system. Mixing metals can create galvanic corrosion, as mentioned earlier. Try to use the same type of metal throughout the system to minimize the risk of corrosion. Consider using dielectric unions when connecting to similar metals. Dielectric unions can prevent galvanic corrosion by electrically isolating the two metals. These unions create a non-conductive barrier that prevents the flow of electrons between the metals. Pay attention to the water flow rate. High water flow rates can increase the rate of corrosion. High flow rates can erode the protective layer on the copper surface, exposing it to corrosion. Try to maintain a moderate water flow rate to minimize corrosion. Also, ensure that the plumbing system is properly ventilated. Poor ventilation can lead to the buildup of moisture, which can accelerate corrosion. Proper ventilation helps to keep the plumbing system dry and reduces the risk of corrosion. Be mindful of the type of solder used for joining copper pipes. Some solders can promote corrosion. Use a solder that is specifically designed for use with copper pipes to minimize the risk of corrosion. Always use lead-free solder to comply with safety regulations and prevent lead contamination of the water supply. Consider the use of corrosion-resistant alloys for fittings and valves. Fittings and valves are often made of different metals than the copper pipes, which can increase the risk of corrosion. Using corrosion-resistant alloys for these components can help to minimize corrosion. And finally, make sure to document all inspections, maintenance, and repairs. Keeping records of all work performed on the plumbing system can help to track its condition and identify any recurring problems. This documentation can be useful for planning future maintenance and repairs.